So here we need to show that this particular expression is equals to 0 when y is given by this particular expression. So let's begin. So here we will start with whatever we are provided with. So we have y equals to log of x plus square root of x squared plus a squared. Let's take the derivative on both sides with respect to x. So this will be equals to the derivative of the logarithmic function. Let me state that. If we have ddx of log x, so that's simply equals to 1 over x. So this means we will get 1 over x plus square root of x squared plus a squared. But then again, this is not x. So that means we will have to multiply it to the derivative of x plus square root of x squared plus a squared. So this is the chain rule. So this gives us derivative of y with respect to x is equals to 1 divided by x plus square root of x squared plus a squared multiplied to the derivative of x with respect to x. So that's 1 plus derivative of square root of x squared plus a squared. So let's find it out. Derivative with respect to x of x squared plus a squared whole raised to the power of half. So here we'll have to use the power rule. So I'll start with this one. So this will be half multiplied to x squared plus a squared raised to the power of half minus 1. But then again, we'll have to use the chain rule to differentiate x squared plus a squared. So this will be multiplied to derivative with respect to x of x squared plus a squared. And we have the rest of the terms. Now we'll take derivative with respect to x of x squared plus a squared. So that's simply equals to 2x. Here a is a constant. So here 2 and 2 will get cancelled. And this is going to give us now we can combine the two terms within the parentheses to get. So here we see that the numerator and the denominator will get cancelled out, and that leaves us with dy over dx equals to 1 over square root of x squared plus a squared. Now we know that we can also express the first derivative of y with respect to x as y1. Now that means we have y1 equals to 1 over square root of x squared plus a squared. What we'll do, we'll square both sides. Squaring both sides will give us y1 squared equals to 1 over x squared plus a squared. So let's cross multiply them. So we have x squared plus a squared multiplied to y1 squared, which is equals to 1. Now what we'll do, we'll take the derivative on both sides with respect to x. We have derivative with respect to x of x squared plus a squared multiplied to y1 squared. So this will be equals to derivative of 1 being a constant, so that simply equals to 0. Now here we will consider x squared plus a squared as the first function and y1 squared as the second function. That gives us x squared plus a squared, which is the first function, multiplied to the derivative of the second function, plus the second function multiplied to derivative with respect to x of the first function, and that's equals to 0. So we have x squared plus a squared multiplied to the derivative of y1 squared with respect to x. So that's simply 2 times y1 times derivative of y1 with respect to x. We'll have to use the chain rule here, plus y1 squared multiplied to derivative of x squared is 2x and derivative of a squared, so a being a constant is 0. Let's further simplify it. So we have 2 times y1. So here we have dy1 over dx. So this is the second derivative. So we'll replace dy1 over dx with the second derivative. Let's state it here. ddx of y1. So that's equals to y2, which is simply the second derivative, multiplied to x squared plus a squared plus 2x times y1 squared equals to 0. Now we'll take 2y1 as the common factor. So this gets multiplied to y2 times x squared plus a squared plus 2 times, we have already taken 2 as the factor. So we have x times y1 equals to 0. Now we know that 2y1 So that cannot be equals to 0. So that means we'll have y2 multiplied to x squared plus a squared plus x times y1. This is equals to 0. Now y2 is simply second derivative of y with respect to x, and we have x squared plus a squared multiplied to it plus x times y1, which is the first derivative of y with respect to x. So this was what we were asked to prove. So let's verify that as well. We have x squared plus a squared multiplied to second derivative of y plus x multiplied to first derivative of y. So x squared plus a squared times second derivative of y with respect to x plus x times first derivative of y with respect to x equals to 0.